Over the years, the number of known elements has gone up from 37 to 118, making it difficult to study them and their innumerable compounds individually. Hence, scientists started organizing them in a systematic way, such that those with similar properties were placed together and those with dissimilar properties were kept separate. After years of experiments and observations, scientists came up with the concepts of periodic table and periodic law. It classified elements in rows and columns such that the periodicity in their properties, that is, the reappearance of similar properties at regular intervals, could become apparent. A periodic law defines the periodicity in the properties of elements in a periodic table. This classification not only helped scientists in comprehending the properties and chemistry of existing elements, but also in predicting the properties of elements that were yet to be discovered. Since 19th century, scientists have attempted to classify elements using different approaches. For example, in 1817, German scientist Johann Dobereiner noticed similarities in the physical and chemical properties of elements and observed that these elements formed groups of three. He called these groups triads. He found that the elements in each triad, when arranged in the increasing order of their weights, demonstrate that the atomic weight of the middle element is the average of the other two elements. This he called the law of triads. For instance, in the triad of soft, reactive metals, lithium, sodium, and potassium, the atomic weight of sodium, 23, equals the average of the atomic weight of lithium, 7, and potassium, 39. Similarly, calcium, strontium, barium, and chlorine, bromine, iodine also formed triads. However, as Dobereiner's law of triads seemed to work only for a few of the known elements, and hence it was dismissed as mere coincidence. In 1862, A.E.B. Deschamps-Courtois arranged the then known elements in order of increasing atomic weights and made a cylindrical table of elements that displayed the periodic reoccurrence of properties. Deschamps-Courtois' periodic table was important because he was the first person who arranged all the chemical elements in the order of atomic weights. Chemists did not give his discovery its due attention because he used geological rather than chemical terms. Slowly, people recognized the significance of arranging elements based on their atomic weights. In 1865, an English chemist, John Alexander Newlands, propounded the law of octaves. According to the law of octaves, when elements are arranged in the increasing order of their atomic weights, the properties of every eighth element are similar to that of the first element. This trend resembled the octaves in music, wherein every eighth note is similar to the first note. Hence, the name law of octaves. For example, in Newland's periodic table, the 8th element after lithium is sodium, and the 8th element from sodium is potassium. All these elements are similar in their chemical properties. However, Newland's law of octaves was not found to be true for new elements found after calcium. This led the German chemist Lothar Meyer to develop a table of the elements that closely resembles the modern periodic table. He observed a periodically repeating pattern of chemical and physical properties against their atomic weight, while analyzing atomic volume, melting point, and boiling point of elements. Unlike Newland's, Lothar Meyer observed that the length of that repeating pattern was not constant and there was a change in the length, and so created a periodic table based on the increasing atomic weights as given on stage. Unfortunately, his work was published after the work of Dmitri Mendeleev. Hence, Mendeleev is considered the father of the modern periodic table. In 1869, Russian chemist Dmitri Mendeleev published a periodic table and corresponding periodic law of 63 elements known at that time. Mendeleev's periodic law states that the physical and chemical properties of the elements are a periodic function of their atomic weights. Mendeleev created the periodic table by listing the elements in a row in order of atomic weights and starting a new row when the characteristics of the elements began to repeat. This resulted in the arrangement where the elements with similar properties occupied the same vertical column. Mendeleev termed these vertical columns as groups and resultant horizontal rows as series. Mendeleev's success roots to his vision of classifying elements based on the similarities in their empirical formulas and properties of the compounds formed by them. This made him to occasionally ignore the order suggested by atomic weights to classify elements with similar properties together. For example, iodine with lower atomic weight than that of tellurium was placed in group 7 along with fluorine, chlorine and bromine because of its similarities with their properties. Mendeleev also left gaps in the table for undiscovered elements. For example, he left gaps under aluminium, silicon and boron in the periodic table for yet to be discovered elements. He not only predicted the existence of these elements and called them Eka aluminium, Eka silicon and Eka boron respectively, but also described some of their general physical properties. These elements were later discovered and named as gallium, germanium and scandium. Mendeleev's confident predictions and their eventual success made his periodic table win accolades. However, there were certain anomalies in Mendeleev's periodic table. These anomalies were: 1. The position of hydrogen was not correctly defined. 2. There was no place for isotopes of elements in his periodic table. 3. The placement of elements having greater atomic mass before elements having lower atomic mass could not be logically explained. In the early 1900s, discovery of newer elements, isotopes, and the development of atomic theories paved way for the development of the modern periodic table.